Welcome back, everybody. Today, no radios, but this is a follow-on from the last video I did, the Lucky Dip one. And a couple of my viewers, Ken and Stuart, hi guys, they both commented to me that, hey, you've got these NOS capacitors, reform them. And Ken also reminded me that I've got this bloody power supply here. And I thought, well, why not? I've never done it before, so let's put it to some good use. I searched around on the net trying to find some real simple video on how to reform, and no, just a number of guys just talking and I'm not learning anything. I want to see things happen. There was an Indian guy. I couldn't understand pretty much what he was saying, but he used a capacitor tester with a magic eye to reform a cap, and that was interesting. I could use my cap tester. But it's the knob to test leakage is spring loaded, and so I'd have to hold it there. I'm not going to do that for hours and hours and hours, and nor am I going to modify my cap tester just for this. So I did find a website that gave a sort of explanation, and anyway, I'm more interested in the schematic that he provided. So as you can see, power supply right over here. And the positive goes through a 30 to 50k resistor. He recommends 5 watts. I've got a 30k resistor at 2 watts. That's going to have to do. And of course, goes to the positive end of the cap, and the negative just fed straight from the power supply. And if we just bridge both ends of the resistor to a multimeter, set to DC voltage, we can monitor the voltage drop, he says. And the way I understand that, and I checked this with Ken, is that, yeah, as current's flowing through and the cap is absorbing DC, the readings I get off my multimeter should drop and drop and drop and drop and drop. In theory, they should go down to 0, but I doubt whether there's any cap out in the world that's 100% efficient. So I would expect some sort of leakage in millivolts. So I'm going to, oh yeah, before I say that, I will put this link in there, underneath, down below, but this guy did say one thing that I didn't agree with, and Ken pointed out to me as well. He says that when you start to reform any cap, look at its maximum voltage rating and just start off at that voltage. And the answer to that is I wouldn't do it. I wouldn't do it. You start off slowly, start off at a low voltage, and you bring it up gradually over time. And in fact, that's what that Indian guy with the cap tester was doing. He just didn't go up to 600 volts. He started off small and built it up over time. So that's what I'm going to do. All right, I'm going to set this up, and where are we? So positive goes to my resistor. Need another jumper. To connect it to the positive and make sure I get my polarity right. Positive to positive. And negative. Actually, sorry guys, I'm going to do something else. I just thought of it. I want to set a benchmark as to what I will expect a reformed cap to look like. So I'm going to grab myself a brand new Electrolytic, and we're going to test that first and see what readings that gives. That was quick. I've got a 24 microfarad, brand spanking new, never been used. And where's my positive? And there's my negative. And grab leads from this multimeter, which will monitor the voltage across the resistor, or the voltage drop across the resistor. Well, there we are. So one end, positive, negative, who knows? Doesn't make any difference. It's positive line. And I'm also going to monitor the output voltage of the power supply with this little multimeter, just more accurate. So where's my positive terminal? Right there. I know you can't see it, but I'm just attaching it to both leads. Right. And I'll start off at minimum voltage. That's a 600 volts, 620, 640. Let's see what we get. We'll give it 20 volts, 23 volts will do. And I'm expecting that to drop and just drop and drop and drop. And it's in millivolts. So that's what I expected. So let's ramp it up to close enough to 100 volts. So it's dropping from, what was it, 2-3 volts, and now it's back into millivolts. Sort of 108, 80, 70, 50, 60, 30, 90. It's jumping up and down. Okay, let's try 174 volts of DC. And we'll jump back into the millivolt range again. It's higher. It's 200, 100. Oh no, it's just all over the place. But anyway, a good indication of how. I'll go even higher. So that's 250 volts. So yeah, increase the voltage input. The voltage drop, well, decreases. In other words, that gets higher and then slowly builds down again. So that should eventually, we're at half a volt at the moment, and it's kicked in back to millivolts. Okay, cool. That's what I expected. I mean, I was reading that article and sort of a bit of a loss with his terminology and that. Clearly he knows a lot more than me. Still got to learn somehow. So where are we? I've got a mess of wires everywhere. Oh yeah. Alright, so here's our old NOS electro. It's positive, negative, and oops, one of my clips has come off. Just need to monitor where we're at. The other side of the cap, the other side of the resistor. Got it? No, you can't see, but yeah, that's the mess. Alright, voltage down to 0, and this can only handle 180 volts. And let's turn it on, and I'll start at roughly 10%. So instead of 180, I'll go 20 volts. I'm not getting anything. Okay. I'll just check my wiring. The common lead off the multimeter had come off. Oh, I didn't put it on. So, alright, start again. And this time I should get some... There we go. 20 volts. And the NOS cap, and she's dropping. 0.9 a volt, 8, 7, 6, 5, 4. And that'll just keep dropping slowly, slowly, slowly. Actually, the power supply's not doing too bad. Look at that. I don't know if you can see it, but geez, you're rock solid. 23.7 volts. Not bad at all. So this is going to take a while, clearly. I'm going to leave it running for about 5 minutes. Then I'll come back and we'll see. Oh, well, actually, we're in the millivolt range. Well, that's all right. I'll still leave 5 minutes. And then I'll crank it up to, say, 50 volts of DC and watch it again for another 5 minutes. Alright, so back shortly. Okay, that's 5 minutes. And, yeah, it's dropped down a bit. It'll probably keep dropping. I think what we'll do... See, I'm not sure how long I really should leave it. Do I leave it for 5 minutes? at this low voltage rating, and after 5 minutes try to raise the voltage. Well, I guess that's what I'm going to do. So I'm going to go up to 50 volts. And as you saw, the voltage climbed up, but it is dropping. And I'm going to leave it here for another 5 minutes. So I'd appreciate you guys that have done this before. What times, or how long you leave them at at various voltage ratings, and do you take it up right up to the limit? And I saw somewhere yesterday some chart said you exceed the limit of the voltage rating of your cap. So in this one, 180, you might take it up to 200. Yeah, well, I think they've got a bit of a buffer there. I wouldn't. I'm too much of a scaredy cat. I don't want things blowing up on me. And, oh yeah, forgot to mention, doing it this way, if you've got a capacitor test, it'll have a discharge function on it. This doesn't. So if you take your cap off, and I'm just looking at that new Myac cap I've got. Now that hasn't been discharged, and I know I don't want to get a shock. So I mean, I've got my, I think I've shown you this before. Let me put the cap down. A capacitive discharger, 2 5-watt resistors in series. They both add up to 920 ohm. A couple of alligator clips. And yeah, if you haven't got one, make one. And this will discharge the cap, and that's safe enough now. So I'll just leave that sitting there. So yeah, you don't want to get a shock. You just pull it off. You pull your cables off. You grab it, and there's 180 volts in there. Bang! That's going to hurt. That's going to hurt. That's going to burn. So anyway, where are we? Well, I've been talking, babbling. Just over half a volt. Sort of seems to be sitting around there, doesn't it? Okay, I'll tell you what, we'll leave that for another 5 minutes, and I'll come back. Okay, another 5 minutes has passed, and yeah, she's dropped down to the millivolt range. Cool. I will, multimeter's gone off. The other one anyway. Yeah, okay, 55 volts. I will just bring that voltage down, and all I'm doing is go to the next level, and that says 60 volts there. Let's take it up to 80. There we go. You can see 81.6, 7, 8, 9, 20, 82. The voltage is creeping up. Down a bit. And what's our voltage drop look like? Is it dropping? Yes, slowly. I guess this is going to be a long, drawn-out process. And I'll probably stick at this for the next 5 hours, I'd say. And then my thought is after that, we'll do a reading on the cap and see if it's actually close to 100 UF. Because they all registered high, like 130, 150 microfarads. So, okay, again, another 5 minutes on this one, and we'll see how it goes. Another 5 minutes, and millivolt range again, that's good. And where are we? 200, 3... Is it going to get any better? I don't know. But this whole process seems to be working. Alright, let's ramp it up to 100 volts. Here we go. And that's good, that's jumped up. And down it goes. Okay. So, another 5 minutes. Well, that's another 5 minutes, and down to just under half a volt. So, I'm thinking I'm just going to leave this at this voltage level of 102 volts until that comes down to the millivolt range. Again, I'm just going to treat millivolts as my benchmark. Oh, there we go, millivolts. And now we're back to volts. Okay. I'll give it 10 minutes, see what it does. Okay, so I've let 10 minutes go by, and I've been watching it for the last few minutes, and it's just sticking in the millivolt range, and sort of all over the place, but it won't go above, like, you know, the highest is in the 300s, and sometimes it drops down to like 0.4 millivolt. But anyway, I'm going to up the power, and we'll take it up from 100 volts up to 130. So I'll just drop it down, flick the next switch, that'll do, 135 volts. All good. So it's, yeah, working, I think, as expected. DC voltage is dropping. Cool. And again, another 5 minutes, we'll come back. Okay, it's been close to 10 minutes, and it's on the verge there between volts and millivolts, as you can see. I'll come in even closer. So I'm going to leave it go for another 5 minutes until it stays within the millivolt range. Well, it's been going for 15 minutes, and I've been watching it for the last 5, and it's just hanging around. It's stabilised on millivolts, and sometimes it goes down to like 0.4. Probably won't do it while the camera's on, but everything's working well on this so far. So let's up the voltage to I'm at 140, so we'll go to 160. Here we go. There we go. And yep, it's dropping. So again, just going to follow this process. So another 10-15 minutes, we'll come back and see what happens. Okay, I've had it on there for 20 minutes, and we're now down on the millivolt range. I'm going to leave it on for another 15 and see if we can bring that down to, so it doesn't register 300, so somewhere around the 200 millivolt range. I'm just curious, and we'll see if that happens. Well, that's another 20 minutes gone, and there's been a significant improvement. It still does occasionally jump up to over 300, and just before I turn the camera on, I saw it register 0.4 volts. So I guess the longer I keep it running, maybe for that 12.4 hours, it'll be fully reformed. But I'm happy with the way it's progressing, and I'm going to up the voltage from 160 to about 175, I think. There we go. And we'll just go through this process all over again. I expect, at least, again, it's all consistent. Raise the voltage, that registers, multimeter registers high voltage running through it, and that's just dropping down. And we'll leave it again for probably 20 minutes, I would say. Okay, I've let it go for actually 40 minutes, and it's, from what I've seen for the last minute that I've been looking at it, yeah, just all in the millivolt range, and from 300 can drop right down to like 100 millivolts, sometimes even a bit less. and it just seems to be doing, I guess, pretty much what the that brand new cap was doing. So I'm thinking, I don't know, either let this run for another hour, and actually I was just reading something on the net, and some guy on one of the radio threads said that he finds 2 hours of reforming is enough for him. And again, I don't know, this is my first time, so it's all trial and error with me, but I will let this go for, no, actually I'll let it go for half an hour, and then we'll come back, I'll discharge the cap, and we'll do a capacitor, we'll measure it and see if it's working. Might even plug it into the cap tester as well. Why not? Bit of fun. Okay, I'm back. I've let this go on for an hour, and certainly the voltage seems to be dropping right down. That's pretty good. What I'm going to do, I'm going to power it all off and discharge that cap, and we'll take a reading on it and see what we get. And yeah, get that on there, get that on there. And let's get that voltage out of it. Oop. Okay. So, let's all set our multimeter up for capacitor checking. Untangle all my probes. That'll be fine. Let's see what we get. Given that it's 100 microfarad, take a little bit of time to charge her up. Yeah, so we're all glued to the multimeter. Okay, 123 microfarad. Okay. Don't know if that was the original amount, but you know, there's a fair bit of tolerance in these, plus and minus. So it's not too bad, I suppose. I'm going to pull out the cap tester, and again, just out of curiosity, and we'll see what the magic eye tells us. A little gizmo's all powered up. Let's stitch our clips onto it, correct polarity, and I've set it up at 25 volts to begin with, and watch the eye. And yep, that's fully open, 25 volts, cool. And 150, always takes a bit longer. Yeah, fully open. And I can't go any higher because it's 350 and it's a bit above the rating. So that worked. That worked. Wow, cool. No leakage. Oh, well, minimal as we saw in the millivolt range. So great. What I'll probably end up doing, I'm going to let the capacitor rest. Again, I don't know if it's right or wrong, but that's what this guy told me, and he was right into electronics, all this old test gear and that, and doesn't hurt. And then I'll run another test on the cap machine and also do another measurement on the multimeter and see if the microfarad value has changed. Anyway, I'll be back in about 3 to 4 hours. Okay, I've didn't let this rest for 4 hours. I'll let it rest overnight, and back again. And let's measure it on the multimeter and see if there's been any change to its capacitance value. Just get the probes around the right way. I think it makes a difference. And here we go. This should take a little bit of time anyway, but you know, let's bear with it. What's that? 0.752 microfarad. Well, clearly that's not good. Alright. Just try and... the flywheel's a bit dirty, so... And wait. Come on, baby. There we go. 111 microfarad. Well, that's come down appreciably from, what was it, 120 something. So, hey, that's all good. Let's get that, let's see if it leaks, the cap tester. Alright, I'll just switch it on. Bear with me for a sec. Okay, unit's all warmed up. Let's get these clips onto either end. Leave it there. I've set it, we'll test leakage at 25 volts. That should be fairly quick, I think. Well, quick enough. Yep, fully opened. So at 150, the maximum that I can test this, well, I would test this at. And that looks to me, yep, no leakage. Super. Well, this has been a complete success, which is really, really good, given it was my first time. The other thing I did read yesterday was, and Ken also mentioned this to me as well, when you, whichever way you're doing it, whether you're doing it with a capacitor tester using a magic eye, or like I did with a power supply and a multimeter, if the voltage, DC voltage, doesn't start dropping within 5 minutes, unplug the cap. It's not going to be reformed, and from what I read on that article, apparently the voltage going through it will be transferred or dissipated as heat inside the cap. And of course, too much heat and the cap will go pop or bang or whatever. So 5 minutes for me, I would have thought personally, because like I said, I'm a scaredy cat, I would have thought if it doesn't do it in a minute or two, then I would give up on that cap. The other thing I was thinking of, what caps will I reform? Well, I mean, this whole little thing here, I know it's only 25 microfarad, 40 volt, but this is something like 73 years old. And I wouldn't be bothered. It's just too old. It's been in a radio for that long, and it's done its job. You can't make them last forever. However, this little sucker, 400 volt at 470 microfarad, this came out of a computer power supply, and I would try and reform this one, because it's only about 4 years old, or 5. So yeah, and of course, new old stock, absolutely. So this is great. Well, I've learned a lot. I hope you enjoyed it, and I will catch you all very, very soon. Take care. Have fun.
So long, Joe. I'll be dropping you a card.
Cal, get off right away. This whole thing smells to high heaven. Cal, I'm begging you, don't go.